Recording started. So today is 2nd November. Okay, good afternoon to you all.
Good afternoon, sir.
Please respond to your attendance. Adi Lakshman, Amit Kesarwani. Amit Kesarwani absent है क्या? Amit Kesarwani is absent. Amit Kumar present. Ankati Vignesh.
Present.
Ankit Kariketa. Absent. Ashok Tiwari. Absent. Ashok Kumar. Biswajit Behra. Absent. Biswajit Behra आया क्या? Challa Kranti is there. Chetan Ajmera. Absent. Devasis Behra. Absent. Google Lotu. Harish. Harshvardhan. Harshvardhan is there. Okay. Himanshu is there. Jagiri. Jagiri is there. एक मिनट जगीरी इज देयर, जिगर इज देयर. उससे पहले रजित कुमार कहाँ से आ गया भाई? रजित कुमार तो नहीं था. रजित यू टेल मी लेटर ऑन. कुणाल अरविंद. मनदीप इज देयर. मंडलिक is absent. Mohit is absent. Nitesh Rajwade. Nitin Anand. Pankaj Das. And then Prashant Prajapati. Priyanshu.
Sir, Nitin Anand present, sir.
Priyanshu.
Nitin Anand present.
नितिन आनंद हाँ प्रेजेंट. लिख दिया ना आपने यहाँ. पंकज के पहले नितिन आनंद लिखा है तो प्रेजेंट है. राजेश कुमार. प्रियांशु के बाद राजेश कुमार नहीं है. राकेश.
Yes, sir, present, sir.
राकेश
Present, sir,
अग्रवाल.
Rajesh.
ठीक है. श्रीचंद्रन बेहरा. श्रीचंद्रन बेहरा. सत्यव्रत नायक. सौरभ कुमार. शुभम पटेल. शुभम दास. सिद्धार्थ. सौरभ आनंद. सुजीत गुप्ता. वकास सिद्दीकी. योगेश. आकाश पवार. अग्निहोत्री. माइक ऑफ कर दो भाई जिसका माइक ऑन है. अमन अग्निहोत्री एब्सेंट. देवांशु. कुणाल. कुंदन राय. राजेंद्र सिंह. रजित कुमार ऊपर दिखा था. ठीक. संजीव कुशवाहा एब्सेंट. सोनाक रे. संजीव कुशवाहा आया क्या? सोनाक रे. वैष्णवी. वकास इम्तियाज. किसका छूट गया ऊपर से देखते हैं.
Sir,
अमित
Amit
केसरवानी.
present.
इज इट देयर? अमित केसरवानी. अंकित करकेटा है इसका.
Present,
आशीष
sir.
तिवारी. आशीष तिवारी नहीं आया. चेतन अजमेरा नहीं है. देवाशीष सस्कम. मंडलिक एब्सेंट ही रहेगा. मोहित कुमार सस्कम. देवांशु. अमन अग्निहोत्री.
Present, sir.
सर प्रियांशु प्रेजेंट सर मैसेज सेंड नहीं हो रहा सर नेटवर्क स्लो है
आज प्रियांशु, कहाँ प्रियांशु कहाँ बोला? अच्छा है, कहाँ है प्रियांशु? प्रियांशु तो प्रेजेंट है ही, प्रियांशु दिखा है
हाँ
कहीं?
सर
हाँ, ये तो है।
वो मैं सर इनकॉल मैसेज में नॉट सेंड दिखा रहा है सर
यहाँ दिख रहा है प्रियांशु श्री सर, प्रियांशु प्रेजेंट सर, नेटवर्क स्लो,
ओके सर ओके थैंक यू
दिख रहा है। राजेंद्र कुमार सिंह, नॉट देयर। तो एब्सेंटीज है राजेंद्र, मंडलिक तो रहेगा ही एब्सेंट, चेतन अजमेरा इज एब्सेंट, एंड आशीष तिवारी, अमित केसरवानी, ये एब्सेंटीज हैं। ओके, so our last practical today consists of two activities. One is the determination of uh, porosity of a rock specimen, and second is the determination of the permeability of a soil specimen. तो porosity का definition याद है या भूल गए? Anybody? Volume of voids divided by the total volume, isn't it?
Yes, sir.
Porosity is defined as volume of the voids divided by total volume expressed as percentage. Okay, so you have a rock matrix, there will be interconnected pores. Okay, and these interconnected pores, so these interconnected pores, water can enter into these pores and they can fill the voids. Okay, so that concept will apply here. We'll submerge the specimen into water. Okay, and let the things fill down in the pores, and then we will do the calculation. So what you do initially is you take the dry weight, then you take the complete saturated weight. Okay, so saturated weight minus that, then dry weight will give you mass of water. Okay, and you know that rho is equal to mass by volume, and for water it is 1 gram per cc. So you can calculate volume as mass by rho. That will be always equal to whatever is the mass. Okay, so basically these voids, they get filled with this much of the fluid. Okay, so and before that you can also measure the volume of the dry specimen. Okay, so then you divide it by volume and you get the porosity. That's a simple method to find the porosity. Okay, porosity का एक मेथड और पढ़ाए थे, that is your helium porosimeter. Okay, so that facility we do have, we procured it, but it's not working in our lab. In fact, that is with the ventilation department, and so far it has some issues with the commissioning. Otherwise, if it would have been working, I would have shown you. Okay. In fact, with that, you can find the permeability of rock specimen also, as well as its porosity. Okay. Anyway, so if you don't have very hi-fi facilities, at least with this method also you can find the porosity of the rock. So let us see one video. What you do is we have taken three specimens. Okay, this one is the coarse grained sandstone. This one is the fine grained sandstone, and this is the marble. And then we try to find the porosity of the three kinds of rock, and we try to see the relations, what's happening. Okay, so the first thing is that you have to measure the dimensions of each of the specimens so that you can calculate the volume. Okay, so that's being measured. Okay, then you take its weight. Okay, so all these things you take the weight, dimensions, clinical area, then note them down. तो दो रीडिंग लेकर उसका एवरेज ले सकते हो आप. Okay, and then you find out the weights of each of the specimen. Okay, and then what you do is in the next step you submerge all these soil specimens into water bath, and you see the kind of bubbles that are coming out from the middle sample. Okay, sometimes you have to tap this water so that whatever air is there in this water, that can be released. See the bubbles coming out. So the air gaps between the uh, matrix are being filled with water. These things you can observe in only coarse-grained rocks. फाइन ग्रेन्स में बहुत डिफिकल्ट है, छोटा मोटा बबल दिख जाएगा. मार्बल में तो दिखना ऑलमोस्ट इम्पॉसिबल है. Visually it is not possible to see, but still it soaks some amount of water. Right. So then you take the after half an hour you take its weight. Okay. And before taking the weight, you just wipe with wipe lightly with cloth. Okay. And then take its weight. So this weight is basically the weight of the water that has been absorbed in the sample. Okay. Then again you put this specimen into the water and wait for half an hour. Okay. And continue this cycle for 2-3 times. Okay. ये बात में फिर से इन्होंने डाला, फिर से ये निकाल रहे हैं. Okay, so every half an hour you repeat this cycle to calculate its weight. Okay, and the observation, and then you have to measure the weight. Okay, so the observations which you take can be tabulated as this way. Okay, is it visible now? Yeah. So the rock type is, one is fine grained sandstone, another is coarse grained sandstone, and third is the marble. Average dia has been noted down. Its average length has been also found and noted down. And with this you can calculate the volume. Is the volume calculation okay? Pi d square b, okay, into length into 10 to the power minus 3, because we want to convert it into centimeter, divided by 4. Right. Okay. So the volume is 330 centimeter cube for this 220 and 239. Okay, then you make another table like this. Okay, so initially whatever rock specimen that was taken, we wanted to drive out all the water which is present naturally in the soil, and for that what you have to do is you have to oven dry the rock specimen to expel out all the water. And what should be the temperature at which the oven has to be maintained? If you want to expel the water, ऑयल में किए थे हम लोग, क्या करते हैं, कितना डिग्री
105.
सेल्सियस? 105 डिग्री, 100 to 105 डिग्री सेल्सियस तक उसको ओवन में रखते हैं फॉर ए पीरियड ऑफ 24 hours, and then we cool down that sample, and then we take its weight. Okay, so this column is representing it 60.3. Okay, 14 and 655.9 as the oven dried mass. Okay, then you submerge the specimen into water, and after half an hour you take its weight. So this fine grain stone weight has increased. Coarse grain stone's weight has also increased, so it has soaked some water. Even marble, which is seen to be very less porous, to absorb some amount of water, and its weight also is increasing. Then again, after half an hour again, you take its weight. Okay, तो फाइन ग्रेन ने थोड़ा और पानी खींचा, बट कोर्स ग्रेन ने अभी पूरा पानी नहीं खींचा, और ये यहाँ 449.2, 449.2 ये एरर आया है इनका. ओके, हो सकता है 449.3 इनका एरर रहा हो, बट एनीवे 449.2 पे रहा. ओके, 656.2 पे ये कांस्टेंट रहा. Again, you submerge it in half an hour. So at the end of 90 minutes, it's 62.6. This has still soaked some water, fine grain sandstone. But the coarse grain stone, almost 1 hour के बाद, हाफ एन आवर में ही ये सारा का सारा पानी खींच लिया. ओके, whereas 1 घंटे तक में इसने पानी खींचा, फाइन ग्रेन ने, और मार्बल को भी जितना खींचना था वो खींच चुका है. एंड आफ्टर दैट all the weights are remaining constant. That means whatever water has to enter into the rock has entered after an elapse of 120 minutes, and beyond that no more water can be absorbed by the specimen. Okay, so how much water is absorbed can be calculated from final weight minus dry weight. Okay, is the formula okay? Yeah, F7 minus B7. Good. Okay, so fine grain sandstone has absorbed about 2.3 gram of water. Coarse grain has absorbed almost 31 grams. And marble has just absorbed 0.3 gram of water. Now the वॉल्यूम ऑफ वाटर, वेट आपका 2.3 है, डेंसिटी को अप्लाई किया ग्राम पर सीसी से, ओके, डिवाइड किया तो इट बिकम सेम वैल्यू, बट द यूनिट्स चेंजेस. So it is 2.3 gram, 31.3 gram. Okay, so volume of voids will also be same, 2.3, 31.3 and 0.3. And the initial volume we had calculated here. Okay, so F2 P13 by D2, P13 by D2, P13 is this divided by D2. Yeah, fine. So this ratio when expressed as percentage, okay, it is 0.7%. Porosity for fine grain sandstone, 15.36% are the voids in coarse grain, and 0.13% is there in marble. Okay, so this way you can find the porosity of the rock specimen in the laboratory. Okay, और ये slate durability, whatever write-up I had given for slate durability index for the ISRM, Few other methods are also mentioned there, and this method can be also applied. Okay, that write up you can get from there. It's an easy method. Okay, now any doubts in this experiment? Okay, direct method, there should not be any doubt. Okay, so okay, then if this is the easiest thing which you have understood, then we move on to another experiment, that is finding the permeability of a soil specimen using this. So this equipment, it looks something like this. Okay, it has a base plate. Okay, and in this group, this porous plate, porous rock can be fitted, and you can see a small hole crossing throughout this plate. Okay, and this is the frame in which the soil specimen can be there. And this red, whatever you see, the shining red, is basically the gasket maker or gasket sealant uh, paste that has been added so that water leakage can be prevented when we assemble all these things. So let us see how it's being assembled. Okay. First, they place the porous rock specimen. Okay. Then you place this drum, hollow drum, and over
सर पोरस रॉक मटेरियल के हेलो सर
ये इसलिए रखते हैं क्योंकि सपोज हियर व्हेन यू ऐड सैंड और सॉइल इनटू दिस, और इसके ऊपर में ये फिट करते हैं, और इसमें हम जब वाटर डालेंगे तो दैट सॉइल शुड नॉट गो एंड क्लॉग द आउटलेट. ओके, दैट्स व्हाई वी यूज दिस पोरस ये रॉक. इनफैक्ट यहाँ पे हमें एक राउंड फिल्टर पेपर भी रखना था. ओके, सो बिकॉज ऑफ द अनअवेलेबिलिटी ऑफ द filter paper, we have done this experiment without a filter paper. Okay,
सर सैंपल के साइड में एक चीज फिलिंग टाइप की कुछ उसमें थी, वो क्या था?
कौन सा
वीडियो बैक करिए, वीडियो सर बैक करिए. ये सैंपल के साइड में जो रेड और सैंपल के बीच में ब्राउन कलर का जो आ रहा है,
ये जो रेड है ना, ये
नहीं सर, रेड रेड के और अंदर ब्राउन कलर का जो एक सर्कल दिख
ये
रहा है. यस सर,
ये उसका ग्रूव है. उस ग्रूव में इसका ये ग्रूव फिट होगा.
जी सर.
This drum has a flange that is
जी
coming
सर,
out, so that flange will fit into this groove,
ठीक है.
right? This way, this drum flange is fitting there, and then you can place the second ring so that it can be tightened. Okay, this was also lying there in the lab unused. We maintained it, then we have used this. I think for the first time we are doing this practical for our students. Otherwise, only the research scholars had done it. In the new syllabus, this has been added. Okay. So this is how you fix this plate. Now this, along with this flange, this cannot come up. Okay, then you tighten all those flange with these nuts. Okay, and then there is a spring. Then these things will be fitted. Okay, so that over this cap can be placed, and a watertight condition can be maintained. Okay, उसके बाद इसमें क्या करती है, रॉक फिल कर दिए, ये सारे स्टैंड लगा दिए, then you fill this hollow portion with soil. Okay, and over this again you have to place this second porous plate. Okay, and then you place this back side में जो cap है that you place there. Okay. So before placing this specimen, you must know what is the area of this soil specimen that is going to be filled. So for that you need the dia. Okay. So dia is noted down. Okay. And you need to know the length also. So the length we will measure it at the end of the experiment when I show you some write up and then how we measure that. Okay. So sandy soil है ये. Okay. This is being filled into the thing. And जैसे आप इसमें प्रॉक्टर टेस्ट में जो इसको कॉम्पैक्ट करते थे, you compact it to a level which you can find in the field. Okay. Or else compact it lightly. Okay. And then fill the other layer. Okay. Compact it lightly. And then you have to place the second stone over this. Okay. And then apply the gasket maker seal paste in this portion. And then you fit it. Okay. Fit this to the top. थोड़ा सेटिंग करना पड़ता है. It is not perfectly 120 degrees. Okay. तो ये फिट कर दिया. उसके बाद क्या करते हैं? There is a knob at the bottom which I had shown you, which had a hole through which water can pass, and inside the soil is filled. And this is from the top, water can go through this. So before conducting the test, we want to maintain a steady state flow of water. That means the complete soil matrix should be filled with water, and that can allow steady state flow of water. So for that, what we do, we give a back pressure of water, and then the water starts filling the matrix, and then from the top it will come out. Okay, so that thing they do with the tap. Okay, when the flow becomes steady, then we close the bottom knob and the top knob, so water is entrapped between this, and then we take this to our experimental setup. Okay, experimental setup हमारा ये है. We need a water column. Okay, so this we can fill the water into this, and you must know what is the dia of the tube. Okay, so that dia they have measured it 1.3 mm, 2.3 centimeter होगा ये. Okay. Madhu, I'm in a class. Can you call me after 4? Okay. So this is nothing but something like a bullet fitted onto the stand, and from that you have again a knob through which water can be flowing through this. Okay, and this outlet is at the bottom. What we have to do is we fill this portion up to this portion, so that with water. Okay, so that water whatever is coming out of this can be treated as a datum level. इस ट्रे के ऊपर जो वाटर लेवल है that will be treated as datum 0, and whatever height of water column is there in this tube, that has a height h. Okay, over that much column of water or pressure of water, rho GH is acting onto the soil. Okay, and then we allow the water to fall to height from H1 to H2, and then we measure the uh, yeah, mm, time in which this is flowing. And then you can use the Darcy's law to find what is the permeability. Okay, तो permeability का जो formula है, that turns out to be this formula. K is equal to 2.3. A is the small a is the cross sectional area of the tube or the buvette through which it is flowing. L is the length of the specimen, uh, soil specimen. Capital A is this total area of through which the water is flowing in the specimen. Delta T is the time, and H1 and H2 are the distances. Okay, so let's first prove this
Excuse me.
probability. Yes, tell me.
Small a, small a. What is small a?
Small a is the area of the this buvette.
Total surface area or
Cross sectional area.
cross section?
Okay, and here capital A is the cross sectional area inside cross sectional area of the uh, hollow drum through which water will be flowing. Okay, so if you see what is permeability, and this experiment is known as the falling head permeability test. Okay, and what is permeability? It is basically the property of soil which will permit liquid to flow through its voids, and that is known as the permeability. So it's the property of soil which permits liquid to flow through its void. Okay, or else in other words, it is the ease with which the water can flow through the liquid, through the soil.
Can we relate porosity and wide ratio with permeability? I mean, more porosity, more permeability. Like
Yeah. Ease with which the water flow through the. Okay, so if you have rock boulders or something, so this will contain more voids, looks to be more porous, so it is more permeable. Whereas if you have soil, sandy soil, the pore volumes will be less, and the ease with which water can flow is very less. So its permeability will be less. Okay. So what we have done, if you see is schematically, what we have done here in this experiment is we have taken the soil sample in between two porous rocks, and we have an outlet here, and then we have an inlet connected to a standpipe, isn't it? And its cross section is A, and here cross section capital A. Okay, so what we have done is we have given a backflow, close the knobs, and now if you close this knob and fill the setup with water, and suppose you have an opening here and this is connected to a manometer, what will happen? The head of the fluid will be same. That means this much head of water is there. Okay, so this is we have not placed this here. It is simply stated, we are stating that if it is at a height h1, then its head, water head is h. Okay, so basically you have filled the A. Okay, now when you open this, the fluid will start flowing out. Okay, and before that, what we have to do is we want to keep it inside a tray. Okay, if you don't keep it inside a tray, so basically what is happening is this exit will also have a pressure. So then you have to find this H1 and then you have to attach a manometer here and then that exit H2 you have to find. So effective height you have to measure. Instead of that, what we do is we fill it with a tub at the bottom. So this level becomes now the datum. And here the water, whatever is overflowing through this, can be collected in a beaker. Okay. And here, whatever exit pressure is there from the soil now is also uh, treated as a data, and data, this is 0. So total height h1 will be basically from this, not from this. This is the total height to which it is flowing. Okay, and then you let it come down to a height h2. Okay, so basically delta h is your change in the height. Okay, and then you have to note that time interval delta t. Okay, and then what? Let us see. Apply the Darcy's law. So Darcy's law, what it says. So what is happening here? You see. Let us see first here. Velocity of flow is proportional to the hydraulic gradient. यही होता है ना Darcy's law. Okay, so V is proportional to the hydraulic gradient I, or we can say that V is equal to K into I, where K is known as the coefficient of
Permeability.
okay, और डार्सी's लॉ में अब लगाएंगे that is Q is equal to K into A into I. So isn't it the flow quantity flowing through this? Okay, so what you see here, this value I, that is the hydraulic gradient. Hydraulic gradient is delta H by L. So for time T1, T2, T3 and T4, what is happening? This hydraulic gradient is going on changing continuously as the water is flowing through this. Okay, so this is not a constant. So we need to derive some other way to see that this can be eliminated. Okay, there is a variation here, and this is continuously varying as the head is changing. So let us take um, one instant t, time t, and at time t plus delta t, only dH volume has moved. Okay, so here let us say that at time t its head is h, and at time t plus delta t, t at time t plus delta t, the head is h minus delta h. Okay, and here since it is a very small quantity, this can be treated as a constant. Okay, so the continuity equation, the continuity requirement, we can say, states that minus the volume of water dropped in standpipe is equal to volume of water collected in this is our beaker. So whatever this has flown, that much water passes through this also, and the same volume of water is collected here. Okay, so how much it has dropped? Minus A into dH. This is the volume of water that has flown through this, and this is equal to Q and into dt, because Q is equal to KAI. Okay, that quantity has flown. Okay, so this Q we substitute here again. It is minus A dH is equal to K A I dt, and hydraulic gradient at time t is equal to h by L, isn't it? So this thing we will substitute here. Okay, so minus A dH is equal to K A h by L dt. So what you observe here is that in this equation, K is constant, A is constant, small a is constant, L is also constant. Okay, L is this length, the length of the soil specimen above the datum. Okay, so your variables are basically H and P. वेरिएबल सेपरेबल लगाएंगे अब हम ए और ए एल डी टी इज इक्वल टू डी एच बाई एच. Then we integrate it to 0 to t for time t, and from 0 if it was at h1, and at time t if it is h2, then k, a, A by small a L into T is equal to log H1 by H2 base E. A is equal to small a L by capital A T log E base H1 by H2. If we convert it into log base 10, A is equal to 2.303 AL by capital A E log base 10 H1 by H2. Okay, so this is the equation to which you can now find the permeability coefficient. Okay, and now here H1 and H2 is known. A is known, L is you can find out from the experimental setup. This L. Okay, H1, H2 we can find. Okay, and the time taken we can find out. And then we can apply this thing, this formula to find the permeability. Okay, as per RES standard, you have to denote the coefficient of permeability at 27 degrees Celsius, and that is denoted by K27. And in the laboratory, if the temperature at which you are measuring is different, say for example at temperature T, then you have to use a correction factor mu T by mu 27, where mu T is equal to coefficient of viscosity of water at temperature T degrees Celsius, and mu 27 is equal to 27 degrees Celsius. Okay, so these corrections can be must be applied. Right. So I'll be sharing with you this RES standard also. Permeability का standard कहाँ गया भाई? ये तो था. Yesterday only I downloaded. And हाँ, soil permeability यहाँ घुसना ये भी नहीं है. Okay, must have been deleted. Okay, I'll download it once again and share you the IS code for that. Okay, so from this experiment, let us make it small. So your diopter specimen capital A was found out to be 9.95 average. Okay, dia of this standpipe was found to be 2.3 centimeter. Okay, and initial head before the starting of the experiment. That means after allowing steady state flow through this sample, and then after filling the standpipe, initial height was measured as, from this datum, was measured as 79.5 centimeter. Okay, and then we opened the tap to allow water pass through this standpipe, and that final head dropped to 73 centimeter, and the time elapsed was 50 seconds to drop from 79 to 73 centimeter. and the length of the soil specimen L was measured as 10 centimeter. So all the units are in centimeter. Area of the standpipe and area of the soil specimen are measured in centimeter square. Okay, and then we apply this formula to find the value of permeability. So formula is okay. 2.303 small a is C11, capital A is C8, small al, length, C8 is length, small al हो गया, into log base 10 C5 by C6. C5 is initial head H1, C6 is H2, correct? Divided by this A into T. Capital A is C12, capital A is C12, and delta T is 50. Right, ठीक है. So this turns out to be this 9.12 into 10 to the power of minus 4 centimeter per second. This is how you calculate the permeability of soil. Okay, कुछ सॉइल्स में बहुत फास्टर रेट से आपका फ्लो होगा. तो द मोमेंट यू ओपन द टैप एंड स्टार्ट योर स्टॉप वॉच तब तक ये बहुत मूव कर जाता है if it is very coarse grained soil. So there you can use a standpipe of greater cross sectional area, one, or altogether you can use the different approach, and that is known as the constant head approach. Okay, so finding the probability through constant head approach, उसमें क्या करते हैं कि you have again a tank that is connected to this. Okay, and then you have a overflow pipe attached to this, and then here you give the supply the water. Okay, so whatever water is there in this tank, so it is always maintaining a constant head. Okay, and then you collect the water in this for a time duration t, and then you can use, since the head is constant, okay, so you can directly use this formula Q is equal to Ka into H delta H or H by the length of the soil. Direct use of this formula can be done to find the permeability. Okay, so that's the another approach when you use it for very coarse grained soils or boulders. Then it can be used. And now we have come to an end. Any queries, any questions? If you have, you can discuss. Okay, fine.
एक्सक्यूज मी सर,
हाँ,
पोरोसिटी और परमेबिलिटी में कोई एम्पिरिकल रिलेशन है क्या?
पोरोसिटी और प्रोबेबिलिटी का
जनरल
रिलेशन, पोरोसिटी ज़्यादा होगा
अगर
तो क्या
इनका
होगा?
परमेबिलिटी कम हो जाएगा, ऐसा कुछ है क्या?
है?
अगर
प्रोबेबिलिटी कम हो
पोरोसिटी
जाएगा.
ऐसा सर, क्योंकि कोल का कहीं देखे सैंपल, अगर वो पोरस है तो उसका परमेबिलिटी कम होता है।
People have tried to find out. Few people may have given the relations, but as such, mm, I have, I have not come across this. People must have given this formulation. They must have carried out experimental study and found out the empirical relation. But that empirical relation will be applicable for only a kind of rock specimen that you are testing. स्पेशली पेट्रोलियम वाले लोग को ज़्यादा यूज़ होता है, स्पेशली व्हेन यू हैव टू रिजर्वायर स्टिमुलेशन के समय उनको उस उस रॉक से पेट्रोलियम निकालना होता है. So they they must be using those empirical relations to get a first hand information about the characteristic of the reservoirs. They must be doing, but I am not aware. I'm not, I have not tried even. In fact, I must say that I have not tried to find out such relations. Must be there.
Excuse me, sir.
Hmm.
Sir, if water content and volume of solid is given, can we find degree of saturation? Is this two parameters enough to calculate degree of saturation? Water content and volume of solid in percentage.
I must tell you, don't try to remember any formula. You must know this. At least these 12 things must be there in your hand. Okay, and then you draw the phase diagram. Yeah, I never use this relation, that relation, other things. Okay, yeah, soil soil mechanics note. इसमें you must solve the problems using the phase diagrams. ये जो आपके 12 इक्वेशंस हैं, I also don't remember this. Okay, and I also don't expect you to remember, because when you go in the field, you will be free to refer them, and in the exam also, you will be free to refer these formulae. Okay, so you must use these formulae first. Okay, and then try to fill the phase diagram. ये इसमें नहीं है क्या? ये इसमें बताया था क्या? नो.
I tried my best to solve this question by using these all formulas, but
फार्मूला नहीं लगाना है, ये यही यूज करना है आपको. बोलो क्या दिया हुआ है.
sir,
Let us try.
volume of solid is 89%.
Hmm? बोलो क्वेश्चन क्या है.
Volume of solid is 89%.
Volume of solid is 89.
Percentage.
Hmm.
Water content is 1.34 percentage.
Hmm?
Water content
Is equal to
1.34%.
hmm.
We have to find out degree of saturation.
Degree of saturation. ये करना है ना.
Yes.
So let us try to draw the phase diagram first. It will contain solid, water, and air. Hmm? This
Yes,
side
sir.
will be volume. Volume of solid, volume of water, and volume of voids. Volume of air. And this is basically the volume of voids. Okay. This side will be mass of solid, mass of water, mass of air कुछ नहीं होगा, and this total is total mass. यही है? Hmm?
Yes, sir. Yes.
And here you can use density and other things. Vol, vo, vo, percentage solid is 89%. Isn't it?
Yes,
That
sir.
is given. Okay, let us use the formula. Mass of percentage solid दिया है, इसका मतलब it has given us mass of solid divided by mass of solid plus mass of water is equal to 0.89. यही हुआ ना? Volume of solid दिया है
Sir,
क्या?
volume of solid, sir, that is.
Volume of solid is 89%.
Yes.
89% of what? Total volume.
हाँ.
Okay. अच्छा, mass है, volume of solid. So volume of solid by total volume is 0.89. So Vs is equal to 0.89 times V. And then water content 1.3%. Water content का फॉर्मूला क्या है? Mass of water by mass of solid into 100. Mass of water by mass of solid
Mass of solid.
100 is equal to 1.34%. So this will be divided 1.34 into 100 is equal to 0. Okay, mass of water, mass of solid. Density नहीं दिया है.
No, sir. Only two parameters are given.
And then you are asked to find
Degree of saturation.
degree of saturation, right? Degree of saturation का फॉर्मूला क्या है?
Volume of water to volume of voids.
Percentage saturations. VW by VG into 100. W by VV into 100. So volume of this volume is basically volume of solids plus volume of water. Can we write it this plus volume of air also, na?
हाँ.
Volume of solids plus volume of voids कर देते हैं. And mass of water by mass of solid. So are you able to get the complete the phase diagram with this information? Volume of voids, volume of water. This is we want to know. So this 100 we remove here. 0.013. 4.
4.
mass of water equal to 0.0134 times
Mass of solid.
If its density is low, then mass of solid by mass volume of solid कंट्रोल। यहाँ से कुछ रिलेशन आएगा। कहाँ का क्वेश्चन है ये?
सर बीके वर्मा।
बीके वर्मा।
बीपी वर्मा, आई थिंक रॉक मैकेनिक्स इंजीनियरिंग पर इंजीनियरिंग। बीपी, बी फॉर बॉम्ब।
बीपी वर्मा। Yes. Mass of water. This relation we want dW by dt. So this must contain air also. Air plus volume of water. Then it will be this. Mass of water. So volume of voids. Volume of voids. Volume of voids will be 0.013 ms.
volume of voice. 0.11 volume of voice.
1.3% है ना?
So 1.3 is water content, that is.
हाँ, तो मास ऑफ वाटर बाय मास ऑफ सॉलिड यहाँ से ये लिया, इसको ये लिया, तो मास ऑफ जितना मास होगा वाटर का ग्राम में, अभी कुछ ग्राम में ले रहे हैं अभी, ओके, ऑल द मास also we are trying to take in gram instead of megagram, okay, so this must be equal to this volume, volume of voids इतना है आपका, mass of solid times the mass of solid, mass of solid नहीं, mass of solid and this mass of solid, volume of voids, mass of water, oh sorry, volume of water हो जाएगा ना ये, volume of water will be equal to 0.0134 mass of solid and volume of voids, volume of voids कैसे निकालेंगे?
Sir, that is mass of water.
अरे बाबा मास 1 ग्राम पर सीसी होगा ना?
Okay sir.
ये एक निकला, एम वॉल्यूम ऑफ वाटर निकला, वॉल्यूम ऑफ वॉइड्स निकालना है मुझे अब, वॉल्यूम ऑफ वॉइड्स के लिए गिवन इंफॉर्मेशन में से वॉल्यूम ऑफ वॉइड्स निकल पाएगा क्या? वॉल्यूम ये दिया हुआ है, ओके, v by vs is equal to 1 by 0.89, isn't it? v minus vs by v is equal to 1 minus 0.89 by 0.89. So this is Vv by V.
Sir, yes sir.
Hmm?
Yes sir, yes.
So Vv is equal to 1 minus 0.89 by 0.89, ये डाल देते हैं यहाँ अभी. This total is 1 minus 0.89 by 0.89, volume of voids मिल गया. और volume of water is this, and mass ms फिर भी आ जा रहा है. How to complete the mass? ms is this, ये हो गया. ms is equal to mass of water by 0.0134, mass of water 0.134 ms, वही चीज हो गया. ms ही आ जाएगा. ms is equal to ms. vb मेरा निकल गया. वॉल्यूम ऑफ वाटर निकालना है. एक तो किसी का मास देना पड़ेगा भाई.
Yes, sir. I am also thinking that at least the density of solid should be given.
One more information is required.
Yes, sir. Specific gravity of solid should be given.
Any other information so that this mass, one of the mass can be calculated, or the mass of soil can be calculated. VW by VV. Okay, so normally I don't try to remember the formula. Okay, this is the approach one has to follow. Okay, try to first make the phase diagram. Okay, then you write down the relations that have been given, and from those relations you need to fill all these values in terms of one another. Okay, and that must be an absolute value. Okay, so ms निकालने के लिए कुछ तो चाहिए, something is required, right? Any other queries? I discard this.
Yes, sir.
And one of the practical, sir, I am in a class. 4 बजे तक फ्री होंगे सर. ठीक ठीक ठीक. ठीक है. हाँ, और कोई क्वेरी है? तो कैन वी assume G of soil? assumption नहीं करना है ना, दिया नहीं है. क्या निकला है? हिमांशु पेपर सामिया है. आंसर इज 12.81%.
Yes, sir. The answer is 12.81. If that is given, I don't know how to type it, but yeah, given answer.
Must have been typing mistake. Must have been a typing mistake. और assume तो नहीं कर सकते हैं 2.65 because they have not given, or must have, should have been given. Water percent, Himanshu, what is writing? Water percent by 11%. 11% volume of birds. कहाँ से निकल रहा है 11% भाई? हिमांशु कैसे निकल रहे हो?
89% solid है ना सर?
अच्छा अच्छा. नहीं, वो voids में भी तो भरा रह सकता है ना. It is not necessary volume of voids में पूरा का पूरा नहीं भरा हुआ है, उसीलिए तो डिग्री ऑफ सैचुरेशन पूछ रहा है. यानी your void is not completely filled. If the void is completely filled, then the degree of saturation is 100%.
Yes, sir. Degree of saturation will be 100%. But he's asking about degree of saturation only.
Ah, so that means it cannot be 11%. Got it, Himanshu? Am I correct or wrong? हो गया क्या हिमांशु? Anyway. और कोई queries or questions, anything which you need to discuss? One of the questions which I had discussed you in the class, in fact, that was from कुछ कराया था ना मैंने एक न्यूमेरिकल, वो इंजीनियरिंग सर्विसेज का क्वेश्चन था. ओके, and in fact that was solved somewhere. Somebody had solved. I don't remember the source. Okay, they had solved it using lot of formulae. ये formula याद रखो, उसको ये करो. So remembering formula is very difficult. Better to use the definitions, fill the ये phase diagram, and it will be much easier to calculate the things. Okay, I feel that there is a requirement of one more data. Sir, could you please explain the quiz question that you have given? कौन सा सॉइल का क्विज या कहाँ का क्विज? वकास वकास इम्तियाज कहाँ, कौन सा क्विज? क्विज 2, 3 प्रैक्टिकल का क्या?
प्रैक्टिकल.
प्रैक्टिकल का. अच्छा, प्रैक्टिकल का आप लोग को दिया नहीं था क्या? ओहो, ये प्रिंट करके रखा है. ये दिया नहीं मैंने. सॉल्यूशन आई शुड हैव गिवन. ओके, लेट अस सी. क्विज को ही निकाल लेते हैं. हम्म. अरे ये क्या हो गया भाई? Join now. Classwork which the first question is standard proctor test as per IS code. ओके, ये तो सबने ठीक बनाया होगा. 25 होगा आंसर. आंसर इज 25. Standard proctor test is not sufficient for both highways and airways. You need ये modified proctor test, especially for highways also. Okay, so the statement is false. Pressure in conjunction with needing is action is applicable for compaction is true. वो जो दांत वाला रोलर देखे थे ना, जो फोटो में दिखाया था क्लास में, if you remember, compaction वाला ही प्रैक्टिकल पे आते हैं. Okay, so that has a needing action. इसके नीचे field compaction. Okay, this it's sheep foot करते हैं. Okay, so this will basically try to knead the sample. Okay, so it's a true statement. 8 is simple. जब सॉइल का वॉल्यूम होना हो तो बंद हो जाएगा श्रिंकेज लिमिट. This is as per IS specification minus 425 mm. ओके. कौन पेनिट्रोमीटर में 80 ग्राम होगा. दिस वन इज 80 ग्राम. और स्लेक ड्यूरेबिलिटी में 20 RPM है. ओके. और 1 RPM तो कितना परसेंट है. 5%. स्लेक ड्यूरेबिलिटी में जो ये आपका एक्सपेरिमेंट है, that error has to be there, and with that error it is the RPM is permissible. Slake durability आ गया. जिस फॉर्मूले सॉइल का जो फॉर्मूला था ये आप लोग का यहाँ भी है, यहीं से दिया गया है. ओके. तो ±5%. A motor drive capable of rotating the drum at a speed 20 RPM. The speed can be held constant to 5%. So 5% of 20 is 1. So ±1 RPM पे भी acceptable होगा result. Okay. So this result is acceptable. Right. Theoretically, the gauge factor of a strain gauge is 2 that we have seen in the theoretical.
सर इसमें एक ऑप्शन मॉडिफिकेशन का भी है, मॉडिफिकेशन फैक्टर और
इसमें मॉडिफाई नहीं कर सकते ना, क्योंकि वो तो हमको ये ड्रम का रोटेशन स्पीड 20 रखो या 21 रखो तो भी रिजल्ट एक्सेप्टेबल होना है, क्योंकि स्टैंडर्ड ही बोल रहा है हमें कि it should have a motor drive capable of rotating the drum at a speed of 20 RPM. You can keep the speed held at constant, but 5% variation तो acceptable है. Okay. So therefore no modification is required. क्या modify करोगे. Any modification formula is given, not given in the standard. So you cannot apply any modification to this. अगर यही 18 RPM पे घूमता तो you have to discard the results. So the results of experiments are not acceptable if it is 18. Right.
ओके सर.
Theoretically gauge factor इसमें तो कोई इशू नहीं होना चाहिए, ये हम लोगों ने तो देखा ही था. 2.0 I have proved it in the class. Average Young's modulus ये भी सब लोग बना ही दिए होंगे. Option is 2. Average slope of the more or less straight line portion of the axial strain curve. Easy thing. Volumetric strain is twice the axial strain plus diametral strain. ये क्वेश्चन में प्रिंटिंग मिस्टेक है, so everybody will get a full marks. It should have been 0.3 mm. Okay, typo error है, so you get the advantage of doubt. Okay, then coming to this modulus of elasticity, the height of the specimen shall be determined nearest to 1 mm. Okay, and for determination of UCs, the stress rate shall be within 0.5 to 1 MPa per second. तो 0.5 to 1 MPa में हमारा kg वाला यही ठीक बैठ रहा है, 0.5 to 10 kg per centimeter square. So this should be the correct answer, second one. Okay, then next is your numerical. अभी करते हैं. ओके, और उसके बाद 19th, मैक्सिमम ड्राई यूनिट वेट ऑफ ए सोइल इज only a maximum for a specific compactive method and the method of compaction also. किस हिसाब से आप कॉम्पैक्ट कर रहे हो, वाइब्रेटरी कॉम्पैक्टिंग कर रहे हो या कितना एफर्ट लगा रहे हो, ये दोनों उनके ऊपर डिपेंड करेगा. ओके, सो थर्ड इज द करेक्ट आंसर. एंड नाउ कमिंग टू द न्यूमेरिकल. ओके, तो the mine management is facing trouble with respect to the delay in supply of load cells for wooden chocks. In order to prevent delay in production, the young engineer comes up with pneumatic solution. Neoprene rubber sandwiched between the two plates in the four corners of the wooden chalk. This has been given. Okay, so if you see the chalk, wooden chalk, wooden chalk support. Okay. In the wooden chalk support, in between these two woods, you can place the load cell. Okay, so instead of placing the load cell, uh, because of the unavailability, the engineer wants to put neoprene rubbers on all the four ends, and then he wants to measure the yeah, okay, load. So let us consider. Uh, Let us consider the four rubbers. फोर कॉर्नर्स में लगा दिया. ओके, वुडन पार्ट को नहीं दिखा रहे हैं. These are your rubbers. So, presuming that the load is constant on all the sides, this will also be B, this will also be P, and this will also be E. Okay, so let us analyze one of them. Okay, so your size is, area is 25 into 10 power minus 4 meter square. So stress is equal to P into 10 to power 4 by 25 Newton per meter, and strain is 5 by 20 is equal to 1 by 4. Okay. Stress by strain is Young's modulus, and that is equal to 320 gigapascal. 0.32 gigapascal दिया है ना.
Sir, gigapascal.
Yeah. 0.32 gigapascal EPA. Okay, so 0.32 into 10 power 9 into 320 into baskets. Okay, so P into 10 power 4 by 25 into 1 by 4 is equal to 320 into 10 power 6 Pascal. 1 Pascal is equal to 1 Newton per meter square. Okay, so P is equal to P20 into 25 by 4 into 10 power टू कितना 642 2 this becomes 200,000 Newton to 200 kilonewton or E is equal to 20 ton. Total load is plus P plus P is equal to 4P is equal to 10. That is coming over the specimen. So the total load is 80 ton. So answer is none. Right? ठीक है? Any more queries? अटेंडेंस छूटा है
Yes, sir.
इसमें ये कैलकुलेशन भेज दूँ या देख लिए? सिंपल है, इसको सेव करूँ या छोड़ दूँ? छोड़ देता हूँ. इस पर छूटा था अटेंडेंस. वो इज दैट
Sir, Amit
अमित
Kesavani.
अमित केसरवानी.
Yes, sir.
अशोक तिवारी, आशीष तिवारी,
Sir, Sir Rajesh Kumar Singh, sir. जी सर.
और भी है कोई? चेतन अजमेरा, आशीष तिवारी. राइट.
एक्सक्यूज मी सर.
हाँ.
सर नेक्स्ट वीक इस टाइम पे क्या होगा? नेक्स्ट लैब में, मतलब नेक्स्ट वीक में.
नेक्स्ट वीक में खाली रहेगा.
ठीक है.
सिलेबस में वो हो गया. क्विज करना चाहोगे तो क्विज ले लो आप लोग.
नहीं सर, थोड़ा आगे बढ़ा दीजिए और आगे कर दीजिए.
आप लोग डिस्कस करो. सीआर
जी सर.
सीआर इज empowered टू कम्युनिकेट टू मी.
जी सर.
ओके, बट कोशिश करो आप लोग की क्विज भी जल्दी कर लेना सो दैट.
यस सर. थैंक यू सर.
ठीक. और कोई डाउट है किसी को? नहीं. सिलेबस फॉर क्विज 2. क्विज 1 कितना पे दिया था?
1 to 4, sir.
1 to 4. 5 to लास्ट कर देते हैं. और इसमें क्या फाइनल एग्जाम भी लेना है क्या? लेट मी चेक.
वाइवा वॉइस. वाइवा वॉइस.
सिलेबस एमटेक वाइवा वो से था. कहाँ गया भाई? लिस्ट ऑफ प्रैक्टिकल इसी में है क्या? अच्छा, लैब एग्जाम है जी. वाइवा वो से कहाँ है? यही था ना?
हाँ सर.
Yes, sir.
लैब एग्जाम है. क्विज 2 भी है, लैब एग्जाम भी है. देख लो आप कब देना चाहते हो. इसमें क्या कुछ कैलेंडर में होता है कि प्रैक्टिकल वाला? लेट मी चेक. फाइनल एग्जाम, लास्ट डेट फॉर प्रैक्टिकल एग्जाम, वाइवा वो से, प्रोजेक्ट रिपोर्ट, इवैल्यूएशन, ये सब 21 नवंबर तक खत्म हो जाना चाहिए. ठीक है. और क्विज जो है वो भी 15 से 21 के बीच में खत्म हो जाना चाहिए. So you discuss among yourself. Let the CR communicate to me.
Lab exam is remaining portion or entire portion?
क्विज 2 लैब का क्विज तो क्विज 4 के साथ हो जाना चाहिए कायदे से. ओके. Quiz 1 should have been conducted somewhere very near to quiz 2 of the regular classes. Okay, and quiz 2 ideally should be conducted at the time when quiz 4 is being conducted. Okay, and lab exam should be conducted just before the start of the end semester exam. Check with your ये पंकज is there or चला गया? पंकज, are you there? इसको जब खोजते हैं गायब हो जाता है कि हाँ पंकज तो है लेकिन गायब है. ओके, गायब हो क्या जी? गायब है. एनीवे, तो ये आप लोग सीआर से डिस्कस कर लो एंड आस्क हिम टू सी द एकेडमिक कैलेंडर. ओके, and then you communicate me. 23 से फाइनल एग्जाम है सर. हाँ 23 से है. कब है एंड सेमेस्टर एग्जाम? 23 तारीख से 30 नवंबर तक. 7 days. Within 7 days all will be finished. So those things have to be done before 23rd.
सर लैब एग्जाम कैसे होगा?
लैब एग्जाम और राइटिंग देंगे और क्या. इसी तरह का जैसे कुछ न्यूमेरिकल वगैरह होगा उसी को बाय हैंड आप सॉल्व करोगे और सॉल्व करके अपलोड करोगे. विच तो चलो आप टिक लगाने वाला कर लेते हो. ठीक है, द मोमेंट यू से एग्जाम तो यही होगा.
Excuse me, sir.
हाँ,
सर लैब एंड सेमेस्टर के बाद दे सकते हैं
एंड सेमेस्टर
के बाद लाइक 27 को हमारा खत्म हो जाएगा देन 28 या 29 को दे सकते हैं.
ideally not possible because I'll have to answer to the administration why I have postponed it because schedule is already fixed by the administration. Okay,
Okay, sir. Thank you.
so I cannot allow. I have to follow the calendar.
क्योंकि सर 21st तक क्विज
I
4 है.
understand the pressure on you, right? But then I am also answerable to violate the deadlines given in the calendar. Okay, so I cannot allow that also. That cannot be allowed. Unless and until it comes from the administration that yeah all the students have problem. The administration decides that ठीक है practical exam आप बाद में कर लो. Okay, so none of the students in this institute are facing problem. Then why exemption should be given to you? That is another question that the administration will ask. Okay, IT systems में थोड़ा सा टफ होता है, especially in the exams because you have to be on your toes. Okay, that you have to bear. ठीक है.
Yes, sir. Thank you, sir.
Thank you.